Your grandfather never bought a bag of fertilizer. Neither did his grandfather. And yet the soil they farmed grew richer every single year. Somewhere between their generation and ours, we forgot how they did it, and an entire industry built itself on us never remembering. Fertilizer is now a $100 billion business, and it survives on one simple fact. Most people don't know that the ground beneath their feet can heal itself, for free, using plants their own ancestors planted for thousands of years. In the highlands of Anatolia, farmers didn't have chemical companies. They had lentils, chickpeas, barley, and a handful of other plants most of us eat today without ever knowing what they can do underground. For thousands of years, the health of a field wasn't measured by what got poured onto it. It was measured by what got planted on it, in what order, and how patiently the land was allowed to recover between harvests. That knowledge kept entire villages fed for generations without a single synthetic input, and it still works exactly the same way today, on any patch of ground, anywhere in the world. Today, we're uncovering 7 of those secrets. Soil-healing crops so old they predate written history, and so effective that if enough people learned them, the fertilizer industry would have a real problem on its hands. Stay with us, because the very first plant on this list was feeding Anatolian soil 8,000 years before anyone thought to put nitrogen in a bag and sell it back to us. Before we get into it, if you care about growing things the way it was done before chemicals took over, hit subscribe now. This channel is built for people who want the old knowledge back. All right, let's dig in. Number 1. Lentils. There's a reason lentils are one of the first things archaeologists find whenever they dig up an ancient Anatolian settlement. In the region we now call southeastern Turkey, farmers were growing lentils almost 8,000 years before the pyramids existed. Long before anyone had a word for agriculture, Anatolian hands were already planting them season after season, and the soil kept rewarding them for it. Here's the part almost nobody outside farming circles knows. Lentils don't just sit in the ground and grow. Their roots form small nodules, tiny colonies where bacteria live in partnership with the plant. Those bacteria pull nitrogen straight out of the air, a resource every crop needs but most can't access on their own, and convert it into a form the soil can use. The lentil plant feeds itself with this nitrogen while it grows, and when the plant is done, it leaves the surplus behind in the ground for whatever gets planted next. Picture a lentil field in the foothills outside a village like Diyarbakır or Şanlıurfa. The plant standing barely knee-high, its leaves small and feathery, easy to underestimate. Nothing about its appearance suggests it's running an underground chemical operation more sophisticated than anything a fertilizer plant can replicate in a factory. But pull one up and look at the roots, and you'll see small, pale nodules clinging to them like tiny beads. Those are the nitrogen factories themselves, working in real time. Anatolian farmers figured this out without a single lab test. They noticed that wheat grown after lentils came in fuller, greener, stronger. So lentils became a rotation crop, planted deliberately between grain seasons, not for their own harvest, but for what they left behind in the dirt. Entire multi-year rotation systems were built around this observation, long before anyone had a scientific term for nitrogen fixation. A legume year followed by a grain year, over and over. A rhythm passed down without ever being written in a textbook. A fertilizer company would have you believe that kind of soil enrichment can only come from a factory. Lentils were doing it quietly for thousands of years before factories existed. If you wanted to try this yourself, lentils are almost embarrassingly simple to grow. Scatter the seed, let the plant do its underground work over a single season, then either harvest for food or turn the entire plant back into the soil before it seeds. Either way, the ground underneath comes out ahead. But lentils work close to the surface, giving generously and yielding fast. The next plant on this list reaches for something lentils never could: depth. Number 2. Chickpeas. Walk through a market in central Turkey today and you'll find chickpeas everywhere, in hummus, in stews, roasted as snacks. Almost everyone has eaten one. Almost nobody knows that chickpeas were first domesticated in this exact region, in south-central Anatolia, thousands of years ago. and that the plant has been quietly rebuilding soil for just as long. Chickpeas share the same underground trick as lentils, nitrogen-fixing bacteria living in their roots, but they do it in tougher conditions. Chickpeas thrive in dry, rocky, nutrient-poor soil where other crops struggle to survive at all. That toughness made them essential in Anatolia's drier inland regions, where rainfall was unreliable and every harvest mattered. What made chickpeas especially valuable to Old World farmers wasn't just what grew above the ground, it was what happened after the plant was finished. Farmers would till the spent chickpea plants directly back into the soil, and as they broke down, they released the nitrogen stored in those roots directly into the ground, feeding whatever crop came after. The chickpea plant itself is easy to miss in a field. Low, bushy, covered in small trifoliate leaves, with a faint downy texture that helps it hold on to moisture in Anatolia's dry inland heat. Its pods hang small and swollen, usually holding just 1 or 2 seeds each, nothing like the dense clusters you'd see on other legumes. That modest appearance hides the fact that chickpeas were often the difference between a field that survived a drought year and one that didn't, because the plant's deep, wiry root system could pull moisture from levels of soil that shallower crops never reached. This is a practice modern industrial farming actively avoids, because a field resting to rebuild itself for a season is a field not generating immediate profit. Ancient Anatolian farmers understood something today's agriculture forgot on purpose: that soil needs to be paid back, not just taken from. Entire villages structured their planting calendars around this principle, treating soil less like a resource to extract from and more like a partner that required its own kind of care. Anyone with a struggling patch of dry, rocky, or neglected soil can plant chickpeas as a first step rather than a last resort. The plant doesn't need rich ground to succeed, and by the time it's finished, the ground underneath it rarely resembles the tired soil it started as. Chickpeas rebuild soil through patience and toughness. The next plant on our list does something almost nobody expects from something so soft and unassuming. Number 3. Fava beans. Fava beans, sometimes called broad beans, have been a staple on Anatolian tables for so long that food historians consider them one of the oldest cultivated crops in the entire Mediterranean and Near Eastern world. In Turkish kitchens today, they show up stewed with olive oil and dill, a dish that likely tastes almost identical to what an Anatolian farmer's family ate centuries ago. Unlike many crops that arrived in Anatolia through trade or migration, fava beans appear to have been growing and evolving alongside the earliest farming communities in this exact region, which means the plant and the people who grew it essentially learned agriculture together, season by season, mistake by mistake. What most people never learn is that fava beans are one of the most aggressive nitrogen fixers of any legume. Their root nodules work harder and faster than most other beans, pulling large amounts of nitrogen from the air in a single growing season. For farmers working exhausted or poor soil, fava beans were often the fastest way to bring a field back to life. There's a second secret buried in fava bean roots. As they grow, their root systems release organic acids into the surrounding soil. Those acids help unlock phosphorus that's already present in the ground, but chemically locked away in a form plants can't absorb. In simple terms, fava beans don't just add new nutrients to soil. They unlock nutrients that were already there and inaccessible. The plant itself grows tall for a legume, sometimes reaching waist height, with thick, upright stems and broad gray-green leaves that give a field a fuller, heavier look than lentils or chickpeas ever produce. Its flowers are striking too, white petals marked with a dark, almost black blotch, attracting bees across an entire field at once. Anatolian farmers didn't just value fava beans for the soil work happening underground. The flowers pulled in pollinators that benefited every other crop growing nearby. Anatolian farmers planted fava beans specifically before more demanding crops, using them as a kind of natural reset button for tired ground. No synthetic input, no purchased bag of anything. Just a bean that's been doing this job since before recorded history, passed from one growing season to the next through nothing more than observation and repetition. Grown at home, fava beans reward patience with speed. A single season is often enough to notice the difference in soil that felt lifeless before planting, without needing anything more than seed, water, and a bit of sun. Fava beans work fast and dig for hidden treasure underground. But the next crop on this list isn't a legume at all, and its power comes from something completely different. Number 4. Barley. Barley might be the most underestimated plant on this entire list because most people only think of it as a grain, bread, beer, animal feed. What they don't know is that barley was one of the very first crops domesticated anywhere in the Fertile Crescent, with Anatolia sitting right at the heart of that early agricultural world, and that ancient farmers valued it as much for its soil-restoring rotation role as for its harvest. Unlike lentils or chickpeas, barley doesn't fix nitrogen. Its power lies somewhere else entirely, in its root structure. Barley grows a dense, fibrous network of roots that spreads wide rather than deep, and that root mass does something crucial. It physically holds soil particles together, preventing erosion during heavy rain and wind, which were constant threats on Anatolia's exposed highland plains. As barley's roots grow and eventually decompose, they leave behind channels through the earth, tiny tunnels that let air and water penetrate soil that would otherwise pack down hard and dry. This process, which modern agronomists now call improving soil tilth, was something Anatolian farmers understood purely through observation. They noticed that ground planted with barley one season was easier to work the next, softer underfoot, quicker to absorb rain instead of letting it run off. A barley field in late spring is unmistakable. Golden green stalks swaying together, each topped with long, bristly awns that catch the light and ripple in the wind like a single moving surface. Beneath that visible motion, an entirely different kind of work is happening in silence. Roots weaving through the topsoil in a mesh so dense that a single barley plant can produce root length measured in miles if you laid it end to end. Barley was also planted specifically in rotation after nitrogen-hungry crops, absorbing what those crops didn't use and preventing nutrients from leaching away and being wasted. A full cycle, working with the land rather than draining it, grain feeding people, roots feeding soil, and the whole system repeating itself without needing anything shipped in from outside the village. Barley is forgiving enough for a beginner to grow, tolerant of poor soil, and quick to show results. Within a single growing season, ground that once felt compacted and dry becomes noticeably looser, simply from the roots doing what they've always done. Barley strengthens soil from the outside in, structurally. The next plant on our list works differently, through fiber, and through roots that go remarkably deep for something most people only picture as a fabric. Number 5. Flax. If you own a linen shirt, you've worn the product of a plant that's been growing in Anatolia since the Neolithic period. Flax is one of the oldest cultivated plants in human history, and archaeological evidence places its use in this region back further than almost anywhere else on Earth. Most people know flax today for two things: linen fabric and flaxseed as a health food, and have no idea it was also considered a soil-saving crop. Flax grows a surprisingly deep taproot for a plant that looks so delicate above ground. That root pushes down through compacted layers of earth, breaking up hardpan soil that shallow-rooted plants simply cannot penetrate. As the root travels down, it creates passageways that let water sink deeper into the ground instead of pooling and evaporating at the surface, which matters enormously in a region like Anatolia, where dry seasons can stretch on for months. Flax also demands relatively little from the soil compared to grain crops, making it an ideal plant to grow on land that had been worked hard the previous season and needed a lighter touch. Farmers got two benefits from a single planting: fiber and oil-rich seed to harvest, and structurally improved ground left behind once the plant was done. The plant itself looks almost nothing like what it produces. Slender stems barely thicker than a blade of grass, topped with small blue flowers that open for only a few hours each morning before closing again, giving a flax field a shifting, shimmering appearance across a single day. It's a strange thing to picture, that something this fragile-looking is simultaneously working underground to break apart soil dense enough to stop a shovel. there's something almost poetic about it. A plant delicate enough to be woven into fine cloth was also tough enough to crack open compacted Anatolian earth that heavier crops couldn't touch. If you're growing on your own land today, flax can be sown in early spring on any patch that felt exhausted the year before, left to grow through summer, then either harvested for seed or simply cut and worked back into the ground before the first frost. You don't need machinery or chemicals, only the willingness to give the soil one season of a plant most people only associate with clothing. Flax works through depth and structure. The next plant on this list works through something far more chemical and far more surprising. Number 6. Sesame. Sesame has one of the longest agricultural resumes of any crop still grown today, with cultivation in Anatolia and Mesopotamia stretching back thousands of years. It shows up in some of the oldest written agricultural records in human history, prized for its oil long before olive oil became the dominant staple of the region. Traders carried sesame oil across the ancient world precisely because it resisted spoiling and heat far better than other oils available at the time, which made Anatolian sesame fields economically vital long before anyone understood the plant's second, hidden value sitting underground. Almost everyone recognizes the name today, from bread toppings to tahini, but almost nobody connects sesame to soil health. Sesame's real secret is its taproot, which drives straight down into the earth, often deeper than many people would guess for a plant of its size. That root breaks apart compacted subsoil layers that sit below where most other crops ever reach, effectively drilling access points that allow air, water, and future root systems to move through ground that would otherwise stay dense and lifeless. Sesame is also remarkably drought-tolerant, which made it valuable in Anatolia's hotter, drier growing regions where irrigation wasn't always reliable. Farmers could plant sesame on marginal land that struggled to support other crops, and the plant would not only survive, but leave that land measurably improved once harvested, looser, more porous, better able to hold what little rain did fall. A sesame plant stands upright, narrow, and unremarkable to look at. Pale, tubular flowers tucked against the stem, easy to walk past without a second glance. The seed pods, once dried, split open with a small, audible pop, which is exactly where the old expression, open sesame, is believed to have come from. Farmers who grew it season after season weren't thinking about ancient folklore, though. They were thinking about how the ground felt different under their feet once the sesame was cleared, looser and easier to break with a hoe than it had been before. There's an old agricultural logic at work here that fertilizer companies have no interest in you learning. The plant that survives the harshest conditions is often the same plant capable of fixing the harshest soil. Modern gardeners looking to try this at home don't need much. Sesame wants heat, tolerates poor soil without complaint, and asks for almost nothing in return besides sunlight and time. Planted on the driest, most neglected corner of a plot, and by the end of the season that corner will noticeably outperform ground that was never given the chance to be worked by a root this determined. Sesame drills deep and survives where little else can. But our final plant does something none of the others on this list can claim. It fights back against the very things that damage soil. Number 7. Mustard. Mustard has a longer and stranger history in this part of the world than most people realize. Cultivated across Anatolia and the broader region since ancient times, mustard was valued by Ottoman-era farmers not just as a spice and flavoring, but as something closer to a working tool, a plant deployed specifically to protect and repair the land. Records from Ottoman agricultural life describe mustard being grown deliberately at field edges and in rotation blocks, not for the harvest alone, but because farmers had come to trust what the plant did to the ground it touched, a trust built purely on generations of results rather than any written science. Mustard's roots can reach 3 feet or more into the ground, tunneling through compacted earth and leaving behind loosened channels that make it dramatically easier for future crops to establish strong root systems. As those roots and the plant's leafy growth break down and get mixed back into the soil, they add organic matter that feeds the microscopic life every healthy soil ecosystem depends on. But mustard's most remarkable trait is chemical. The plant produces natural compounds in its tissue that act as a biofumigant, meaning that when mustard is grown and then worked into the ground, it actively suppresses harmful pests and pathogens living in the soil, the same kind of soil-borne threats that modern farming often treats with synthetic pesticides. Ottoman-era farmers had no microscope and no lab, but they had generations of observed results. Fields planted with mustard beforehand consistently grew healthier crops afterward. Bright yellow mustard flowers turn a field into a solid sheet of color by late spring, tall enough to sway at the waist, dense enough that walking through one means brushing against blossoms the entire way. It's one of the more striking sights in Anatolian farmland, and for centuries it doubled as a quiet warning sign to anyone who understood what it meant. This ground was being protected, not just planted. Mustard even has a documented ability to draw certain toxins and heavy metals up out of contaminated soil, a process now studied formally, but practiced instinctively by farmers who simply noticed that mustard left the land better than it found it, every single time. For anyone wanting to try this today, mustard is one of the fastest results on this entire list. Sown thickly, it can be ready to till back into the ground in under 3 months, making it one of the few soil-healing crops you could plant and see the benefit of in a single season, rather than waiting years. 7 plants. 7 mechanisms fertilizer companies would rather you never think about. Nitrogen pulled from thin air. Hardpan soil cracked open by roots reaching for depth. Pests suppressed without a single chemical spray. And land rebuilt not by what's added to it, but by what's grown on it, season after season, exactly the way it was done in Anatolia for thousands of years before anyone thought to sell dirt health back to the people who already knew how to make it themselves. None of these plants are rare. None of them require money you don't already have. Lentils, chickpeas, fava beans, barley, flax, sesame, mustard. You've eaten at least half of them without ever knowing they were quietly capable of doing a fertilizer company's entire job for free. That's not an accident that history forgot. It's knowledge and industry had every incentive to make sure you never learned in school. A field in Anatolia didn't need a delivery truck or a subscription service to stay fertile. It needed a rotation, a little patience, and plants that had already proven themselves over thousands of years of quiet, unpaid work underground. The next time you look at a bag of fertilizer on a shelf, remember that everything inside it is an attempt to replace something a handful of seeds could do on their own, for free, the way it was done in these hills long before anyone thought to sell the solution back to the people who already had it. If this changed the way you think about your own soil, do 3 things right now. Like this video so more people see it. Subscribe if you want more of the old Anatolian knowledge modern farming left behind. We're bringing back a new piece of it every week. And drop a comment telling us which of these 7 plants surprised you the most, or which one you're planting first. We read every one, and we reply to as many as we can. This is the Anatolian Peasants Farming. We'll see you in the next one.